In today's video, we're going to look at the second half of section 7.6, which is the normal distribution. So the first thing that I want to look at is the idea of the inverse norm. So in our calculators so far, we have been using normal CDF. Now I want to look at the inverse norm. This is where you are given an area under the curve and you actually have to find that outcome, which has the probability that z, our standard normal distribution variable, is less than or greater than that value given an area under the curve or given a probability for that particular outcome. So we need to find the outcome given the area or probability. That's the first thing that I want to look at. Then we're going to look at what I was talking about last time, where we've done everything in terms of the standard normal distribution so far. I want to look at, okay, what happens if we don't necessarily have a mean of 0 and a standard deviation of 1? How can we convert between that normal distribution and the standard normal distribution? Because like I said, everything used to be done in terms of the standard normal distribution. They used to convert everything into that distribution and then go ahead and just use the mean of 0, standard deviation of 1. So we're going to look at how to do that. And then we'll talk about the calculator and just easily plugging this in depending on what your mean and standard deviation is. So first of all, I want to look at, given an area, can we find what the outcome is? So this example comes from the textbook. The next couple examples come from the textbook. And they've asked if the probability, again, whenever we use z, we know we're looking at the standard normal distribution. I'm looking at what is this value of z such that the probability that my variable is greater than or equal to that value is 0.1056. So I'm looking for the outcome such that the probability that I am greater than or equal to the outcome is 0.1056. Whenever you get one of these problems, I would recommend going ahead and drawing it first. Okay. Like I said, you've been given z. Okay, you know that your variable is z, telling me that my mean is 0 and my standard deviation is 1. And like we said in the last video, you tend to find that roughly 2/3 of your data lies within one standard deviation of the mean. So between, in this case, because we're looking at standard normal distribution, between -1 and 1, so one standard deviation either side of the mean for our standard normal distribution, I should have roughly 2/3 of my data. So roughly 2/3 of that curve should land between -1 and 1. And you can go ahead and plot out a few more points if you want. And then it says that the probability that z is greater than or equal to this particular value is 0.1056. So I'm guessing z is going to be somewhere around here. I'm not sure which side of 2 it's going to land on, but we know that roughly 1/10 of our curve, so 0.1056, should land above that value. Okay, so if this is my z value here, okay, this is what my outcome is, then roughly 10%, 10.56% of my whole curve should land under the curve above that value. Okay, because we're looking at the probability that z is greater than or equal to that value is 0.1056, or 10.56% of my curve should land above that value. Okay. If we had a less than or equal to, then my z value would be somewhere over here. Okay. If we said what's the probability that z is less than or equal to a particular value is 0.1056, then I would know that 10.56% of my curve would land below that value, telling me that z would land somewhere over here. Okay. But like I said, we're looking at a greater than or equal to problem, so I know that 10.56% of my curve has to land above that value, telling me that we're somewhere on the right as opposed to the left. Okay. Now we know that the area under our whole curve is 1, okay, because you have a 100% chance of falling somewhere, okay, of having some kind of outcome. So the area under the whole curve equals 1. Okay, we know that that's the case. So what I need to look at in order to plug this into my calculator, and this is a big deal, when you go to inverse norm on your calculator, so we're going to go to second distribution, and then we're going to go to inverse norm. It's the third option down. It will ask you for the area, the mean, and the standard deviation. The area that you plug in is not necessarily the area that you are given. Okay. In order to calculate that value, it wants the area to the left of the value that you want. Okay. At the moment, we know the area to the right of our value. We know the area above z. We need to find the area below z. You always plug in the area that is to the left of the value that you are trying to find. So the area for inverse norm, the area is always the area to the left of the value that you are trying to find. Okay. Right now we have the area to the right of the value that we are trying to find. So I need to find, I'll do this in blue, this whole area to the left in order to plug this into my calculator. So in this case, the area would be 1 minus 0.1056, which gives me 0.8944. Okay, so that is the area that I would plug in to inverse norm. Okay, so in order for your calculator to figure out what that value is, you always plug in the area to the left of the value that you are trying to find. It's always the area to the left. So you may have to do some manipulation like I've done here. If you have a greater than or equal to problem, you will have to go ahead, do some manipulation and find the area to the left of that value that you are trying to find. Then it will ask you for the mean and the standard deviation. Well, like I said, we are told our variable here is z, telling me we are in standard normal distribution, so my mean is 0, standard deviation is 1. So again, you type this into your calculator. And when you do that, you put in the area, the mean, and the standard deviation on inverse norm. Remember, you find inverse norm by going to second and that distribution button. Then you go ahead, it's exactly the same place that we found normal CDF. You go ahead and go to inverse norm and you type in the area, the mean, and the standard deviation. And when you do that, the value that you should get back is roughly 1.25. Okay. So that tells me that this value z here, such that the probability that we are greater than that value is 0.1056, gives me a value of 1.25. Okay. The other type of problem that you can get, and it's the same problem, but this time they're just going to phrase it slightly differently. Okay. And this is to do with percentiles. So this time it's going to ask, what is the 95th percentile of the standard normal distribution? Standard normal distribution, we know that we're going to be using z, so we'll start out with this. Okay. It's asking for what is the 95th percentile. That's asking me what is the data point such that 95% of my data lands below that data point. That's what this means. That's why I kind of wanted to go through. It's just a different way of saying exactly what we have done before. When it asks for a particular percentile, it is asking for the data point such that in this case, 95% of my data lies below that data point. Okay. Now again, we're looking at standard normal distribution. So I know I'm using Z. We are looking at what is the outcome such that the probability that I have a data value that is below that outcome is 0.95. So whenever they give you a percentile and they say, what is this particular percentile in the standard normal distribution? Standard normal distribution, we know our mean is 0, standard deviation is 1. We know that our variable that we always use for notation purposes is Z. So I'm looking at the outcome such that the probability that I am less than or equal to that outcome is 0.95. Okay, so again, I need to find this outcome. Again, I would always draw this. Okay. We know that we've got our mean of 0 in the middle, and roughly 2/3 of my data lands within one standard deviation of the mean for a standard normal distribution. I'm looking for what is this value Z such that to the left of that particular outcome, I have an area of 0.95 under my curve. Okay, remember, area equals probability. So I'm looking at, if I've got an area of 0.95 under my curve to the left of this outcome, what is my outcome? Well, again, I'm looking for an outcome. I'm going to use inverse norm. Okay, it will ask you for the area to the left of the value that you are trying to find. Well, we have the area to the left here, so that's easy. We can just plug in at 0.95. We don't have to do any manipulation here. Then our mean is 0. Our standard deviation is 1 because we're looking at the standard normal distribution. When you go ahead and plug this into your calculator, you should find that the value that you get back is 1.65. Okay, so that tells me that 95% of my data is less than 1.65. Another way of stating this is that 95% of the values are less than 1.65 standard deviations above the mean. That is true for standard normal distribution because we have a standard deviation of 1. So two ways that we could phrase this. 95% of our data points are below 1.65, or for standard normal distribution, we can also say that 95% of the data points are less than 1.65 standard deviations above the mean. Okay, so that's true because we have a mean of 0 and a standard deviation of 1. So because we have a standard deviation of 1, 1.65 is just 1.65 standard deviations because our standard deviation is 1 and our mean is 0. So we've got a 95% chance of being less than 1.65 standard deviations above that mean. So in this next example, I want to kind of backtrack to what we did in our last video. And I want to look at converting between any normal distribution that has any mean and standard deviation and going back into the standard normal distribution and looking at how we can do that. So the first thing that I want to look at is this example in order to display this. I want to look at finding the area under the normal curve. So that's, remember, area is the same as probability. So I'm trying to find a probability here. Find the area under the normal curve where we've got a mean of 3 and a standard deviation of 2. And I want to go between 1 and 5. I'm using X here because I'm no longer in standard normal distribution. I've just got this random normal distribution where I've got a mean of 3, standard deviation of 2. So I no longer have 0 and 1. So I know I can't use Z to denote it. We're going to use X in this case. Okay. So that's what I'm going to do here. I'm looking at what's the probability that my random variable X is between 1 and 5. Let's go ahead and draw this and you'll see exactly what this problem is asking. Okay. We have a mean of 3 and a standard deviation of 2. So if I plot out one standard deviation either side of my mean, one standard deviation below is 3 minus 2, which is 1. One standard deviation above is 3 plus 2, which is 5. I'm looking at, remember in my problem, what's the probability that I'm between 1 and 5? So this is essentially asking what's the probability that I'm within one standard deviation of the mean. We'll come back to that in a minute. I'll plot out a couple more points here. Okay. So I'm looking at what's the probability that I am between 1 and 5. Now I told you whenever you sketch these as a good guide, you should be looking at roughly 2/3 of your data should be within one standard deviation of the mean, just because it gives you a good guide for a sketch of this stuff. So you should already realize here that the problem has asked, what's the probability that I'm between 1 and 5? Well, 1 and 5 are one standard deviation either side of your mean of 3, because you've got a standard deviation of 2. So we know that our answer should be roughly 2/3. 0.66 is a rough guide. We know that that's roughly what we should be looking at here. Okay, so let's go ahead and find this using our calculator. So we would be looking at normal CDF. It's going to ask you for your lower limit, your upper limit, your mean, and your standard deviation. So it always goes in that order. Lower limit is 1, upper limit is 5, your mean is 3, your standard deviation is 2. So you just go into your second distribution, go to normal CDF, and you can plug those values in. Because we're looking for a probability, we're looking for an area, it's normal CDF. In our previous problems that we've just done, we've been given an area, we're looking for a data point. So in that case, we use inverse norm. So if you're looking for the area or probability, you use normal CDF. If you're given the area or probability and you're looking for the outcome, you use inverse norm. So we go ahead and plug that into our calculator, and you should find that you get 0.6826 roughly on your calculator. Okay. Like I said, that's roughly 2/3. We know that 0.666 recurring is going to be 2/3. So we know that that should be about right. Okay, that's a good, 2/3 is a good approximation. That's why I always say that to you whenever you sketch it. But let's think of this in terms of our standard normal distribution again. Okay. Coming back to our picture, like I said, we're looking at what's the probability that I'm within one standard deviation either side of the mean. So if we were to draw this as though we had standard normal distribution, it would be the same thing as asking with a mean of 0 and a standard deviation of 1, what's the probability that our random variable z, because I'm looking at standard normal distribution, is between -1 and 1? So you should find, if you go back into normal CDF, okay, and you plug in a lower limit of -1, an upper limit of 1, a mean of 0 and standard deviation of 1, you should end up with the exact same answer. Okay. All we have done between these two curves is we have shifted downwards. So we had a mean of 3. To get to a mean of 0, I would take my curve and shift it downwards by 3 units. And then what we've done is we have squeezed it. So let's look at what we had here. We had the standard deviation of 2. Our standard normal distribution has a standard deviation of 1. So you should find that this original curve is just a lot flatter than our standard normal distribution curve, which is this, which has much more of a hump. So what you're going to do is you're just going to squeeze this thing. So we've shifted it and then squeezed it, and you should end up with actually the same area under that curve. It's just now narrower but taller than our original curve. So you can go between the two, and the areas should be the same if you are just looking at this in terms of standard deviations. Okay, so like I said before, you're given these random data points. What's the probability that you're between 1 and 5? Well, that looks like a completely alien problem to us, okay? Until we think of it in terms of standard deviations. It's the same thing as saying, what's the probability that I'm 1 standard deviation either side of the mean? So what's the probability that I'm within 1 standard deviation below the mean and 1 standard deviation above the mean? So what we did was we said, okay, if I had that exact same problem, but in the standard normal distribution, I would be looking at what's the probability that I'm between -1 and 1 when I had a mean of 0 and a standard deviation of 1. And you should find that the two areas are the same, because all you have done between these two curves is shift it, and then you're going to squeeze it so that you have a taller curve but a narrower one. So the areas actually end up being the same. So whenever you get a problem like this, you can actually convert between the two. And you're going to use this formula if you ever get asked to do this. And like I said, nowadays you can do this on a calculator. Like I said, just use normal CDF. Let me come back to here. Just use normal CDF. You can plug in your lower and upper limits. You can go ahead and plug in whatever mean you have and whatever standard deviation you have, and you're good to go. But previously, they only had statistical tables, and specifically they only had statistical tables for the standard normal distribution. So any other normal distribution that they had to convert to the standard normal distribution in order to calculate any of these areas. We don't need to do that anymore because we have calculators. This is more just a lesson of converting between the two, because up until a few years ago, this is what they had to do. So like I said, you can still convert between the two, and you're going to use this formula. Okay, I'm going to use our last example to show you that this is the case. We were looking at what's the probability that x is between 1 and 5. We had a mean of 3 and a standard deviation of 2. What this formula should do when applied to each of your x values, it should put it into z values, meaning that we can go ahead and then use the standard normal distribution. So this formula will take each of your values from whatever normal distribution you're in into that standard normal distribution. So let's apply this throughout our equation here. So we take each of our x values, we subtract the mean, we divide by the standard deviation. X, we're just going to use algebra in the middle. And then I've got our x value 5 minus our mean of 3 divided by our standard deviation of 2. When we do that, 1 minus 3 is negative 2, divided by 2 is negative 1. X minus the mean divided by the standard deviation we say is z. 5 minus 3 is 2, divided by 2 is 1. So in terms of the standard normal distribution, we are looking at what's the probability that z is between negative 1 and 1. Hence, we're now in the standard normal distribution looking at exactly the same thing as before, but this time we've got a mean of 0, standard deviation of 1, and we're still looking at what's the probability that I'm within 1 standard deviation of the mean. Okay, so this is kind of just to show that it works and to show you what formula you would use in order to do this. You may be asked to use this formula a few times, but most of the time for most of these bigger problems like we had back here, you're just going to plug this into your calculator and it will do it all for you. Like we did before in our last video, if there is a problem where you don't know your lower or upper limit, just type in a very large negative value for a lower limit or a very large positive value for an upper limit. Okay, they will have to be large just to make sure that you are enough standard deviations away from the mean. So like I did before, I think I used negative 1,000,000 and 1,000,000 for my examples in the previous video. Just make sure that they are large enough positive or negative numbers, depending on whether you're looking for a lower or upper limit, just to make sure that you are enough standard deviations away from that mean to make sure that it will catch all data points to give you the most accurate answer. So whenever you use your calculator, if you need a lower limit, it's a very large negative number. If you need an upper limit, then go ahead and use a very large positive number. But here we're looking at what's the probability that we're between two numbers. So we already have a lower and upper limit. Let me go ahead and do one last example of this just so that you can see this in action. So we're going to look at this distribution that has a mean of 12 and a standard deviation of 1.5. We're going to find the area under the curve between x is equal to 11.25 and x is equal to 15. Let's draw this out first, and then we can kind of talk about this in terms of standard normal distribution and how many standard deviations we're looking at here. So our mean is 12, so 12 is in the middle. Let's plot out at least one standard deviation or two standard deviations either side of the mean. So one standard deviation above would be 13.5, one standard deviation below would be at 10.5. And then two standard deviations above would be at 15. Two standard deviations below would be at 9. Okay. This time we're asking what's the probability that we're between 11.25 and 15. Okay. 11.25 is half of a standard deviation below the mean. Okay, it's 0.75, which is half of 1.5. So we're half of a standard deviation below the mean and two standard deviations above the mean. Okay. Now, like I said before, when you type this into your calculator, you can just use normal CDF. Your lower limit is 11.25, your upper limit is 15, your mean is 12, and your standard deviation is 1.5. You go ahead and plug all of that into your calculator and you should end up with 0.6687. Okay. So like I said, these are easy to do on a calculator using normal CDF. If you have a greater than or equal to or less than or equal to problem where you need a lower or upper limit So for a less than or equal to, you'll have an upper limit, you'll need a lower limit, so you type in a very large negative number. If you've got a greater than or equal to problem, you'll have a lower limit, you'll just need a very large positive number for an upper limit. So whenever you've got one of those problems, just type in like a million, 10 million, something like that, just something very large, positive or negative, if you do need an endpoint for a lower or upper limit. But in this problem, again, we have been given our lower and upper limits. We can just type those in. We can type in our mean, type in our standard deviation, and we're done. So in terms of our standard normal distribution, we should be looking at what's the probability that z is between negative 0.5 and 2. We know that that should be the case, but let's go ahead and use our formula to show that that is the case to convert between the two. So in this case, we've got what's the probability that x is between 11.25 and 15. I'm going to apply my formula. My mean is 12, my standard deviation is 1.5. I go ahead and use my formula. So that would be 11.25 minus the mean of 12 divided by my standard deviation of 1.5, x minus the mean over the standard deviation, 15 minus 12 over 1.5. 1.25 minus 12 is 0.75. 0.75 divided by 1.5 is a half, 0.5. X minus the mean divided by the standard deviation is z. Sorry, that should be a negative out the front. 11.25 minus 12 is going to be negative 0.75 divided by 1.5 will give me negative 1/2. And then on the other side, I'm going to have 3 divided by 1.5, giving me 2. So whenever you get one of these problems, this is all you're going to do is use that formula just to clarify what you would be in standard normal distribution. The same would work if you had a one-sided problem. So let's say they're looking for the probability that x was, I don't know, greater than or equal to 15. Okay. If I wanted to convert that to standard normal distribution, you're going to use that same formula. So that's the same thing as saying what's the probability that x minus the mean over the standard deviation is greater than or equal to 15 minus 12 over 1.5. So we would be looking at what's the probability that z is greater than or equal to 2. So what's the probability that I'm more than 2 standard deviations above the mean when I'm in standard normal distribution. Okay, it's still looking at the same thing regardless of whether you have a two-sided problem where you have both limits or you have a one-sided problem. It doesn't matter. But either way, you can either use the formula like that and then go ahead and plug it into your calculator as standard normal distribution with a mean of 0 and standard deviation of 1, or you can just type it in with whatever mean and standard deviation you're given with the original values. It's way easier that way. But the reason that they used to have to do it the other way is just because when you're using statistical tables and you've only got one table that uses the mean of 0 and the standard deviation of 1, everything had to be converted into that before doing any calculation. But nowadays we can just use the calculator, like I said, with normal CDF.